Hi, welcome back to my channel and welcome back to part 4 continuation, where we'll complete our first session observation using K-Star Indi and the Raspberry Pi. In this section we'll talk about the desktop VNC server startup, polar alignment, plate solving, focusing, selecting your target, and then finally imaging sequences. So with this, we're tying everything together into the final video, and I hope you find it interesting. I did run into some issues with the mount, which I left in the video with minimal editing. So without further ado, let's get started. Before we go into the polar alignment, one of the requirements is to have a VNC server running. This is to allow a telephone with a VNC client to display your desktop screen. To do that, bring up a terminal and type in X11 VNC space dash forever space ampersand and then hit a return. The ampersand will place the process in background. Once you've done that, go ahead and minimize your screen, and then you're all set to start the polar alignment process. It's dark enough to where we could start doing the polar alignment. Bring up the Align tab, verify that the guide scope and the camera are set correctly, verify that the exposure and gain are adequate, press nothing, and then just solve and capture. Now the telescope is set up for 0 position, which is pointing right at the polar area. One of the reasons why we're doing this is just to check to make sure that the exposure is adequate and we could solve for the object. And we have, and it's pretty far off. If we go and bring up and look at the K-Star's planetarium program, let's bring this around to where it thinks it is. And so that's this square here. Let me expand up. This is where the solver field of view is located. So it solved and captured and solved the image correctly. Let's go ahead and do the polar alignment. Again, the telescope is in park position and it is up in the 0, pointing at the maximum declination of 90 degrees. We want to make sure there's adequate motion so that we could go westerly at 30 degrees. We want to verify that the mount speed is at a fairly high rate. At 8x is fine. And we hit the start button. Now this will go through 3 images, solving for the first image, calculating, and then continuing on and coming up with a calculation to where we need to point the telescope using the azimuth and elevation settings of the mount. So it captured the first image and solved. It's doing the second image now. You can see the star field rotated slightly. You'll see that the image rotated slightly where it plate solved on the planetarium. And then finally we come up with an image as shown here. Now if you have problems doing this, you want to verify that the field of view is set correctly, and it's correct based on your guide scope of the focal length and the F ratio. If you have problems solving, make sure that you have plenty of stars in the image so it can calculate the location. Stellar solver is what we're using down here to plate solve, and it's fine. It's the default. So let's get back to our image here. I'm going to push this over a little bit and expand this up. Bring this down slightly. Thought I would be able to bring that. Yeah, there we go. So this image, this is calculating how far the telescope is off from the location. zoom in on a bright star and click on the location. You'll notice that if I click here, it probably is a bad star because it will want to push it down over here. I guess that will work. Let's see if this one will work. Click on this, right? Try and be as accurate as you can. You could zoom in. So this is the star I've chosen. Once we've chosen a star and we could move to that, we hit next. If it's outside of the area, in other words, we can't find a star that it's just too far off, you could still click a star and just try and move the star as far as you can towards the point, the target point. So using both, the azimuth and elevation. And then redo the polar alignment, and you'll notice it'll get better and better as each time you do it. If you're really far off. So we're going to hit next, and we're going to select the refresh. This is the refresh period of time where it'll take the exposure. Usually 1 or 2 seconds is adequate. You want to move the altitude knob so that it points to where the yellow line is showing. In this case, you want to put the star over to here using the altitude knob. Then you want to adjust the azimuth knob, which is the green, and move the star towards the center of target. Now you could haphazardly just move the star over. That will work too, but the idea is you want to take this star here and move it over here. So again, I find it easier just to use adjust the altitude knob first and then adjust the azimuth knob. Now this is where a VNC server comes into play. You want to have the VNC client running and connect up to your desktop. I just minimized that window, and then the next thing we do is we bring up our VNC client on our phone. We bring this up on our phone, and I'll try and show this at a different point, but you could zoom in on this display, and it's just like you're at the screen, but you're actually using the VNC client. So with the target located, I'm going to go ahead and hit refresh, and it'll start doing the refresh cycle, as you can see here. So we want to move this star down to here. So I'm going to go ahead outside. Now that you move the star in the target area, you're done. You could hit the done button. And this completes the polar alignment. Now let's go ahead and do the next step, and that is to move to a target so we could focus. I normally pick a target somewhat close. I'm going to pick this target here. So I will go ahead and skew the telescope over to that. Once the target or the telescope's moved to the target, we could solve for that. I'm going to go ahead and change the guide scope back to primary and the camera back to the primary camera, and I'm going to select skew to target. I'm also going to select the solution results and then solve and capture. What this will do is this will solve and capture the current image, as you can see here. Let me shrink it back down because I've expanded You can see we're not even close to the target. And each time the mount model will be updated with the correct information, and it'll get better and better. And as you can see here, it's trying to figure out where it is. And it looks like it failed. So this is interesting. Let me go back. If this happens, I'm going to suggest going back to the guide camera and the guide scope and solving again. This should give you a broader area, and it should be easier to resolve this image. Okay, I had nothing but problems, and I think it is an issue with the VM that I'm running under and passing the time function over to the mount. So now that I've had this set up, I have the telescope pointed over to Arcturus, and we're going to go ahead and do a plate solve over there. And we want to choose the guide scope and the guide camera and solve and capture. This should solve properly. And it looks like it did. It's going to slew to the target. Take another picture. Why am I not seeing the image on the screen here? It's interesting. I'm not sure what's happening now. Let me stop this. All right, let's try this again. Let me go ahead and make sure we're in the guide scope and the guide camera and solve and capture. What's the mount doing? Let's take a look at that. Let's go over to the mount. Oh, because it shows that it's parked. Let's unpark it. For some reason it was in the parked position, and it could have been just because of the way I moved the telescope. Let's go back into the alignment, and it did do it. So the whole issue here was the telescope was in the parked position, and it wasn't allowing me to move the telescope to find the proper plate solving. I'm going to leave this in here because it might be useful for somebody to see it. Sometimes you just have easy nights, and sometimes it's hard nights, and you scratch your head. But I think we're in business now. We have this telescope aligned. Ekos is working correctly. It's plate solving. The next thing I want to do is show you focusing. So let's go over to a target. And what I'm going to do is look for, I'll go over here to this. I'll go over here. So I'll move the telescope over to this target here. And then I'm just going to randomly take a picture and focus it with the primary. Now before we do anything further, I'm going to go back to the align, change it to primary scope and to the ASI main camera. I'm going to go ahead and do another solve, capture and solve. Let me shrink the image. That must be the target we want. Slew detected. Okay. A satellite too. So again, it finds it. It centered it. You have this bullseye here. You could verify with that, or if you want to center something exactly. This is this feature where you could actually move the telescope and center it on a different object if you want. But that's beside the point. Let's go back into the focusing. And I am going to just slightly move this off because I don't want to have a bright star for focusing. I'm just going to go and skew it slightly off. And I am going to start the auto-focusing routine. Now, this is set up again for my focuser, and everything looks as it should. We've already gone over these settings, so I'm going to go and hit autofocus. So it moves the, you could tell by down here, it moves the focus inward and outward. Oh, and this is still a bright star that I didn't want to do. Well, we'll just let it see what happens. This is where dark frames are important, and I did not create any dark frames, so just be aware that it could be a little more difficult. If you have a dark frame library, it's probably better. And I haven't cooled down the telescope or the camera yet, and that would probably be the next step. But as you can see here, it is slowly determining the focusing point. It should actually be, I'm not sure what it's going to be. I moved the telescope quite a bit, so 840 might be about what it should be, but we'll let it do its thing. Should actually start coming up pretty soon. The default center point for my focuser is 819, and usually when I turn off and restart the scope, it resets it to 819. So usually 819 is usually the sweet spot, and it looks like that's the case for this. So it's helpful if you know the focuser and seeing what your characteristics are. I always keep track of the steps where it finally focuses it, and from there I could determine, does that look good or not. Where are we at? We're at step 819 or 818 now. So it's still doing its algorithm to determine the focus. Boy, there's a lot of satellites tonight. I think that's about the fourth frame I've seen with a satellite. Okay, after all that, it came back with the step 811, so we were just a little bit off. It took some time, unfortunately, and it took 29 iterations. It should be better the next time. But your focuser may vary. Mine seems like it has a little bit of backlash, and it is very fine. It's running off a fine adjustment, so I don't know. It works for me, and it was cheap, so we'll keep with that. All right, let's go ahead to the next step. So we have the main we have the main camera focused, and now we're ready to choose our target. And since it's a real smoky night, and that could play in a lot of issues with seeing tonight, so I am going to take a look at favorite M13 Hercules Globular Cluster. So I am going to select this as a target and go to it. I am then going to go over to the Align and solve and capture using the primary scope and camera. And you'll notice that these numbers here reference this here and where they're located. So 11 was found off over here, but now 12 is found right in the center. So we're center onto the target. Let's take a look at the guiding. Now this is going to be variable for your system, and you may have to play around with this. So you might want to have a dedicated night just to learn how to use guiding with Ekos. I think by default it's not too bad. You need to know the guiding rate, of course. My guiding rate is 0.6 rather than 0.5. The other thing, and I mentioned earlier, is you have the various different calibration algorithms that we use. I am going to assume that we're going to be in business. Here's an important thing that you might need to be aware of is the clear calibration data. If you clear this, it clears out the calibration and it forces it to do a calibration. Let's go ahead and just hit the guide button. And you'll see that it's on target. And now it's selecting the guide. And now what it's going to be doing is going through the calibration. Now we can find and look at the calibration plot over here. And we want to really see kind of a nice L manner. I don't really worry too much about this. I know that my declination has a little bit of backlash. Let's just see what happens here. I'll go back to the drift plot. The drift plot is the targeting, and you could watch the auto guiding and how accurately it works going back and forth. The star is a bit bright for this, but I'm just going to let it do its thing. We'll see how it works. So guiding has started. And it's moving around a little bit, but not too bad. I don't know how well this is going to work tonight, but it seems like we're on a good start. I like to keep the guiding range right around below 50. When it gets above 50, you start seeing more and more issues. Certain things that you could try, of course, is under control. You could change the minimum pulse. Reason why mine is so low here is the fact that I was over pulsing the minimum, which would overcorrect and had a number of issues with that. You can see it's starting to come up, which is not a good thing. Let's see what's going on with the plot. Yeah, see, it's kind of off over here and it's getting back. We'll just have to keep an eye on it. Again, I'm worried about scene conditions. It's really smoky out there, so I'm not sure how well this is going to work, but we'll see. You could also increase your target area to expand that. And it just expands out the area so you could take a look at it. So in other words, this is 1 arc seconds, 2 arc seconds, etc. We're above 50, so it's okay. I would like to see it below that, and I don't know why it started out so great and it kind of got weird. So we'll just follow it. Again, it could be just seeing. Anyway, so we're guiding. It looks okay. Next step would be to go ahead and set up your exposure. I am going to do 30-second exposures, and I'm going to have, let's say, 10 of them for this demo. The gain is going to be unity gain of 100 and offset of 10. We're going to be shooting lights. You'll see the prefix has already been defined as M13. Now, since I switched desktops, I'm actually over in a different desktop, and the directory is different. I'm going to leave it. Doesn't matter. I'm going to only start if that's, and I'm going to keep it kind of high. Well, we'll keep it kind of high for the demo. I don't want to sit here spinning our wheels. Is there anything else we need to set here? Everything else looks good. Did I miss anything? No. I'm going to go ahead and add the sequence. And I'm going to start. So now we're in progress. We're actually capturing 30-second exposures. So let's go over to our summary setup page. Here you'll see the status is focused. Guiding is okay. It's still 50. If it gets higher up, then I'm going to worry more, but this is adequate. And our status for capturing is going on. So we should see the first image come out here. There it is. So here's our first image of the Hercules globular cluster. What it's doing here is it's dithering, as you can tell with the status. So it moves the target slightly, and then it should start recapturing. And it is. It's starting to capture again. Here's our overall percentage of completion. Here's the number of images we've taken, and here's the current image exposure setting that we're counting down. So I'm going to let this continue, and I'm going to pause this, and then we'll pick this up. Okay, so that completed the sequence, and as you can see, we're at 100% and with a sequence of 10. If I go back to the camera, and let's say I want to rerun that sequence again, I can use the reset status of all jobs, continue. This goes back to idle, and then I can go ahead and run the sequence again. And this will start the sequence. As you can see here, it's starting again. Now I've been having some problems with guiding, as you can see here through the guide, and it's not liking it. I'm not sure what's going on with it. If you go into problems like this, sometimes it's a good idea to recalibrate. So let me show you how sometimes you could do that. If you go back to the camera and select pause sequence, and I guess it aborted the frame capturing. Well, it's dithering right now. So it's capturing. Let's go back to pause. We'll pause after the current exposure is complete. Then what we're going to do, select guide once this completes, and stop guiding, throw away your calibration, and then hit the guide button again. What that should do is it will run the recalibration again. Like I said, the evening is probably pretty bad out there because of the smoke, but at least you could see some of the issues that you might have and what to do. Oh, and the other thing that we probably should be doing is the bin level needs to be changed, and I just noticed that. So let's stop this, change the bin to 2x2, and go ahead and recalibrate. Let's see if that helps. I normally have bins set for 2x2 for guiding. So once we reestablish guiding, I'll go back and unpause and start the capturing again. All right, we finished calibration and guiding is started again. The other thing you could also try playing around with is exposure. Sometimes if you have too fast of an exposure, you kind of are fighting it. This looks a little bit better, as you could see. So let's go back into our camera and hit the start sequence again. And it should take off where it left off, and it did. So let's go back to our status page and we'll see how we did. And I noticed that our Guiding is creeping up again. Anyway, we'll go ahead and let this finish. And I think that's all I want to cover right now. I don't know if there's anything else I want to cover. If after watching this series, if you have something that you want to cover, let me know, and I'll do my best to do that. I will show you the analyze. Again, this is useful information. It gives you how the targeting has been going through the session. We have an abort here because it probably was pretty bad. We also have another abort here because it didn't meet criteria. One other thing I might want to mention is the meridian flip. We're not close to the meridian, so we don't have to worry about it, but if we were close to the meridian, it would give you the meridian time when it's going to flip. And if you're flipping during an image, it will go ahead and realign to the target and then start capturing again. There's no interaction after a meridian flip, it's all automated. So I think with that, I'm going to stop the video here, and I don't think there's anything else I need to cover as far as operation. Please play around, learn the system, make goals for yourself. In other words, you know, maybe the first night with Ekos, you just want to do a polar alignment. Maybe the second night you want to go through the way the mount works or focusing. Baby steps until you get used to the program does work wonders. And as you could see tonight, I've had my battles with it, but I think I overcame most of the issue. And I'm still scratching my head a little bit looking at the mount and going, why is the time off? I suspect that there is a built-in battery, and I think the battery might not be holding the time. So anyway, that's another story. With that, I'm going to go ahead and stop recording, and we'll pick up for the final comments. This concludes my Ekos Indi installation on a Raspberry Pi 4 series. I hope you found it interesting. My next videos may include using PhD external guiding, bench testing, cable management, some imaging sessions, and possibly some live sessions if you're interested. If you are interested in any of those videos or others, please leave a comment and let me know what you'd like to see for next videos with Ekos Indi or Raspberry Pi. And also, let me know if you're interested in a Raspberry Pi 4 image that I've used for this series. This will allow you to essentially just DD the image over to an SD card and you're all set to go. So let me know if you would be interested in that or not. With that, I want to thank you. Thank you for watching. Thank you for supporting me and this interesting endeavor. And clear skies. Take care, everyone.